Good day. I am Abhay Radhakrishnan from Red Hat. Today we are going to see a demonstration of Red Hat OpenShift AI, mainly focusing on the large language model deployments. We will go through some of the user interface settings and features, but our focus is mainly on the model deployments. So we will be using the project catalog and use the model core approach to do the large language model deployment, and we will do Meta Llama as well as IBM Granite models in that approach. And the tool provides a capability to add custom catalog source. So we'll be deploying a model from Hugging Face, and likewise we will also deploy model from a custom repository using a model core approach, and as well as storing the models on a S3 bucket, and there will be a Google Gemma deployment from the bucket. And we will also demonstrate the GenAI Studio to have the ability to test the models, and briefly touch upon the hardware profiles and the server runtimes. Red Hat OpenShift AI is deployed on top of Red Hat OpenShift using the operators. So we'll be having a Red Hat OpenShift AI operator installed, and there'll be some prerequisites in order to deploy that operator. We'll be documenting that in a associated GitHub document that I'll be sharing later. And we will have a data science cluster, and that will determine what features will be enabled in the Red Hat OpenShift AI. So it kind of provides a great flexibility to decide which features we want to enable and which features we don't want to be enabled. So the KServe will be managed. That means it's going to be available to deploy model using the KServe approach. And we will also have the Red Hat OpenShift AI model registries that will be enabled to avail the model catalogs, and the workbenches will put it as managed to be able to do the data science as needed. And most importantly, the dashboard, which will be managed, which will look at the Red Hat OpenShift AI dashboard, and also Llama stack operator, right? That will allow us to look at the GenAI Studio. So once the Red Hat OpenShift AI is deployed, it will be available as a menu option within the Red Hat OpenShift console. So we're going to click on that. And what we are looking at is the default Red Hat OpenShift AI dashboard. And we are looking at the different projects and the hardware profiles. So we'll be deploying models using the hardware profiles that determine the CPU, GPU, memory, and other accelerator features. And then we will have some data connections that provides different ways for us to deploy the models. And the tool also comes with certain standard serving runtime features, but we'll be focusing on the very efficient optimized VLLM NVIDIA GPU serving runtime using KServe. So that will be the one of the very optimized and very powerful feature. And then we can see the model catalog settings. It comes with the default, but we will be adding a particular catalog source in this process. Now let's look at the models from the menu. And the Red Hat OpenShift AI already comes with certain available models. These are all validated by the Red Hat AI product, right, as you can see here. And they are also benchmarked on the different hardware platforms, right? So we'll be walking through some of the benchmarks here. While these particular hardware configurations will help us to use it, suppose if you are installing, let us say, in AWS or IBM Cloud, you can use this configuration to kind of find an equivalent machine to be able to deploy the models. And then the other option we have is the Red Hat AI models. These are available from Red Hat and IBM. So now let's look at the model, and we are going to create a project, right? Project, or the namespace, is a way we kind of organize the different resources. So I'm going to create a project called model-deploy-UI. and we can see a few options here. Now let us go ahead and deploy a model from this project catalog. So I'm going to choose a Red Hat AI model called Granite 338B instruct model, and this model is available, as you can see, as a model car in the URI, and we'll choose the generative AI model. The approach is kind of similar even when we do the predictive or the machine learning models. So we'll choose a project that we just created, model deploy UI, and the deployment name, I'm going to make it a simple Granite 338B instruct. So we are going to use this particular model from the catalog, and as far as the hardware profile is concerned, we have created a hardware profile called demo GPU that allows us to have enough memory, CPU, as well as the GPU accelerator resource in order to deploy these models. And then it automatically chose the VLLM NVIDIA GPU runtime that we saw earlier. And then this model will be available with an AAS at endpoint, as well as we will have it externally available so that we'll be able to access these models from outside. And it's very important to have these two parameters here: the ability for the model to use the tool, as well as a parser. In this case, it's a Granite parser. So we choose all the different options are deployed here. The main thing being the model car, which is very efficient in terms of caching. It will be a faster deployment, and it's also immutable so that people cannot tamper with that, and also good for efficiency and caching as well. So I started the deployment, and it's going to take a little bit of time. In the meantime, we'll be going through some other features. So let us look at another model that I deployed earlier. Right, I'm going to choose that this is a Llama 318B instruct model, and I installed it on ARK test project. So we can see an internal endpoints available within the OpenShift framework and within the network, as well as an external endpoint. And we are going to add this to the playground feature. Right, this provides a simple way for us to ask a question. So we have installed a Llama 318B instruct model, and we asked a simple question regarding the highlights of OpenShift, and the model is able to provide these details. But at the same time, I'm going to ask the model about the ongoing World Cup FIFA 2026, right, and see whether if the details are available regarding the different schedule. All right. So needless to say, the large language model do not have information about the ongoing World Cup 2026 because it was kind of prepared earlier without that information. This is where we are going to use the retrieval augment generation approach, so that the playground tool provides a way to add knowledge documents, right? So I have added a few documents here regarding the schedule for FIFA, and also the results of the group matches, right? And I enabled the RAG button, and I'm asking kind of the same question, right, regarding the tell us about the group stages schedules. Now you can see we are able to get these details available as part of the RAG. So the tool kind of uses the large language model uses the tool RAG to in order for us to bring these details, right, using a tool called as file search. And now I'm asking it, give it in a very simple format, right? Who played against whom and who won the match. So it is able to provide those kind of details using the RAG approach, right? So this is a way to do the retrieval augment along with the additional documentation here. Now let us look at the current status of what's going on with the model deployments. So I took you to the Red Hat OpenShift to see what is happening with that particular deployment, and it is doing a particular pod as part of the deployment, and I am seeing the logs here that provides what is the current status, right? So now we notice the model deployment that we started earlier is ready at this point of time. And we'll go to the playground and add that asset point to the playground. So this is similar to what we demonstrated with the llama model. This one is the granite model, and I'm asking again a simple question here, right, regarding the OpenShift, and it is able to provide the information. So likewise, you will be able to use, so we'll cover more on the different settings that are required in order to get the knowledge documents and MCP features later. But for now, just to demonstrate, it is as simple as, we are able to click the link to add the particular document here. And so I'm able to upload the files, right, in order to augment the model. Now, let us look at the model catalog settings. So we saw earlier the Red Hat AI validated, Red Hat AI and the other models on the catalog. And this is where it is coming from the model catalog settings. But I'm going to add a new resource, right? So it's called as, I'm just calling it a simple name, Granite 3.2 models. And I'm going to pick these from the Hugging Face. So you'll be able to either get from a Hugging Face or from another custom repository using a YAML file. So, but again, I want only certain models in from Hugging Face, which is a repository of so many models, just that starts with Granite 3.2 prefix, right? So when I did the preview, it is bringing me all the different models from the model catalog. Now, just to give a quick look on that, right? So when you go into the Hugging Face, if you say IBM-Granite organization and the Granite models, you will be able to see this list. This is what pretty much gets pulled into it. So just to show that particular list where it started. And there are other organizations also host this, but we specifically asked for the IBM-Granite organization. You can also choose to exclude the models, and I'm going to add this as an additional source, right, to already available catalog. So what's going to happen here is these custom added models, right, they are going to be eventually added. So now I'm looking at the hardware profile that we used to deploy this particular model. While waiting for that, so demo GPU is the hardware profile model. You can also search on demo-GPU, and you can see the CPU, memory, and the NVIDIA accelerator that we added. And in the hardware profile, we create what we call it as a toleration, right? That it looks for a key called nvidia.com/GPU, whether that key exists. And we will be using a process called tainting on the nodes, right? So only the model that we are deploying using this accelerator, right, will be deploying on those nodes, right? So that's the objective of tolerations and the taints. Now I go to the model catalog settings back, then it is kind of added. So I'll go into the AI Hub models. So we'll go into the catalogs, and when we click on the other models, right, so we'll find the newly added catalog source is included here. And you can see that Granite 3.2 models, right? So that will bring those 9 models that we see added in the project catalog for ease of deployment. Again, from a deployment perspective, right, model core deployment is always faster, efficient, immutable. But at the same time, the one from Hugging Face streaming is popular, but it is going to take some time. As you can see, the model location here is HF colon IBM Granite. So we are going to pull it from the Hugging Face while deploying these models, right? So comparatively, it is a little less efficient than the model core approach that we saw earlier while deploying. So I'm going to choose the same thing, choose the model deploy UI and select the name, and we are going to give the description. So this will be very similar to how we have deployed the earlier model, but this time we are using a custom source from Hugging Face streaming process. Selecting the demo GPU, and you can also modify for a specific model from demo GPU. Suppose if you want to add or reduce any specific resources, it's possible to do from the custom angle. And then it picked up the VLLM NVIDIA GPU, and we are going to make it available as a asset endpoint so that we'll be able to see it from the playground. And now, as for the custom runtime argument, we will enable the auto tool that will allow us to go to the RAG or the MCP, but the tool parser here again is Granite. So I'm deploying this particular model. In the meantime, let's go ahead and look at some other additional features. Now we are going to look at the third approach. That means we do have the images of different models available in a repository, in this case Red Hat AI services. So I'm showing you a Llama 3-18B instruct model, right? It is kind of available, and if you look at the information page, you can look at the URL for that particular thing, right? So this is the third approach we are going to use to deploy the model. But here I'm going to choose the URI, right? So that will be pointing to the location from the Red Hat AI services, right? So we have, that means we have a model image available in a registry, external registry, that we are deploying at this point of time. And suppose to reuse this, it's good to have a connection, right, available for that particular location, but it is again an optional feature here, right? So we are going to create a connection, and then again generative AI model. Again, it will be similar even if you do the predictive machine learning models as well, right? So we are going to call user-friendly model deployment name for this, Llama 318B. So again, we are using the efficient model core approach. So the models are packaged as images readily available to deploy, right? That's the objective here. So we are choosing the similar defaults like the other models that we deployed earlier. Right, and it's always good to have a token authentication, right? So that that will be more secured and a standard way of doing it. And as far as the custom runtimes goes, the one difference you will find it is the parser that we choose, right? So now we are going to start the deployment from an external registry on a model core. So as you may notice, right, it takes more time to stream the model from an external source like Hugging Face, but model core will be much faster. So let us go ahead and it's kind of deployed faster as well. So let's go and add the Llama model we just did from the external registry as a model core, and we are going to do again a simple testing here. So explain the benefits of OpenShift. So I'm asking a simple question. Again, it follows the same approach, right? So in order to add the knowledge documents and MCP, we'll cover it in one of the future sessions, but this is just to demonstrate the completion of the successful deployment of this. Now we are going to look at the custom catalog Granite model that we installed earlier. Again, depending upon the models, the results will be different depending on what the model provides us here. All right. Now let us go ahead and look at yet another approach. So I'm going to choose the particular project and we'll create a connection. So this time we are going to deploy a model using model stored in an S3 object. So I'm going to create a location to my S3 object. So I have used Minio as my object storage. You can have your AWS or any other S3 compliant storage in this process. So I'm just simply calling it as a model S3 location. And this is the place to store the models, either it is generative AI models or the predictive machine learning models. They're all the same thing. So we are given the access key and secret key for the S3 object buckets, and the endpoint is the API endpoint for the object storage. And in this case, I'm just simply giving the region any. And this is the object store Minio, right? We have created a bucket called Gemma models. So I'm going to give the name of the bucket here. So this connection is pointing to that particular bucket, and we'll be able to deploy the models, using this particular connection when we deploy the models. So I'm going to click on the deployment, and we'll choose the deployment model option here. So we'll choose an existing connection that we already did connect to the S3 object, and we chose the model S3 collection we just prepared. And as far as the path is concerned, this is where we are storing. So I kind of downloaded this model from Hugging Face, and I stored in this particular repository. So these contents will be similar to the what we see in the Hugging Face here. And some of these models, in order for us to download, we will have to kind of give a small approval process within the Hugging Face. So you can do that as needed. But the same thing is not necessary when you do the model core packaging, because you already downloaded to a repository. So I'm choosing the same generative AI path, and giving a user-friendly name for the model deployments. Google Gemma 3 model deployment using S3 object storage location, and choosing the demo GPU. And again, it automatically chose the VLLM NVIDIA runtime, and similar defaults again. And since this is a Gemma model, we will be giving a particular parser called as Pythonic, right? So that's the parser that we'll be using for it. And there are two options in the deployment. Either it can be rolling update, that is on the same particular node, it will create another version while the other version is active, or you can do recreate. Recreate kind of helps you with the resource, in order to save the resources, you can use the recreate. But if you want to have two versions simultaneously running, then rolling is another good strategy. So now I kind of have the Gemma model deployed successfully, and let's go ahead and complete the testing for these models. So I will add it to the playground. And I'm asked a simple question just to test, what is the capital of Spain, and then also asking a question regarding the advantages of OpenShift to Kubernetes. So just a recap, right? So we created a project called Model Deploy UI, and then we are showing the different aspects available. You can create a workbench, you can have the different deployments that are available within the same project here. And on the AI Hub, we kind of use that, and we use the project catalog. So we used one of the available models, right, that we chose from the Red Hat AI models tab here. So this model is already available in the default catalog that we saw. So we use that to deploy, and we used the powerful model car approach here, right? It's fast, efficient, and immutable and scalable, right? So that's why the model car is a very popular strategy to deploy. Then we went ahead and going to do the model catalog settings, right? So we added a new catalog source, right? So this time we added this from a Hugging Face repository, right, and picked up the IBM Granite model starting with 328B. That is the second approach we did, and then we deployed yet another model. So we do have an external repository, Red Hat AI services and QA.io, and we do have this model images available. So we use this particular model images again, the model car approach, but the image is available in an external registry. So we use that. And the last one we did was using S3 object, right? So we stored the models in a particular S3 object bucket, and we kind of installed from the S3 object bucket. And we kind of use the GenAI Studio and the playground features in order to test these different models that are in a ready state. So in order to support these, right, so we have created a machine sets in the OpenShift console, and I use the G6E X large, so that kind of provided me enough resources to deploy these models, right? So when I create the machine sets, we remember the toleration that we discussed earlier. So we have kind of tainted these nodes, right, with a particular key called nvidia.com slash GPU, and this tainting kind of helps only the large language models can be deployed on the hardware profile that we chose, right? Not all the other workloads, right? So that way we are kind of efficiently using our expensive GPU based resources. And we have a demo dash GPU, right? That's where we kind of created the features with the required hardware profiles, GPU accelerator, and most importantly, what we did was we kind of have a toleration available with nvidia.com slash GPU as the key. Thank you, and soon I'll be sharing a GitHub to help you recreate this.